Hey party people, Techno here, and in this video we are back at the Sans Holiday Hack Challenge 2022, ready to tackle the next challenge in our quest to recover the web ring. In the previous video, we helped Alabaster look through some packet captures, do some analysis, and sort out some various attack vectors in the Boria artifacts PCAP. And in this video, we're going to be tackling the next challenge, which is opening the Boria mine door. So jumping into our badge, we can see that the Boria mine door is a 3 out of 5 Christmas trees, making it a medium difficulty challenge. And our objective here is simply stated as open the door to the Boria mines. And if we help Alabaster snowball in the web ring, we'll get some hints for this challenge. So let's jump down to the hints and see what we have that will give us a few more advantages when we tackle this next challenge. So our first hint for the Boria mine door is this input validation hint, stating that developers use both client and server-side input validation to keep out naughty input. And here we have a link to the OWASP cheat sheets where we can get some more background information on input validation and just get a quick read up on that. Our next hint is around content security policies, and it states that understanding how content security policy works can help with this challenge. And here again, this will give us a link to OWASP where we can get some of that background on content security policies and how they work. And then the last hint that we have is about the lock mechanism itself. And this states that the locks take input, render some type of image, and process on the backend unlock. To start, take a good look at the source HTML and JavaScript. Okay, so that's a good hint. That's going to give us, right off the bat, we know that we're going to want to look at the source code, and that we also know that whatever input we're giving is being rendered into some type of image. That could be useful to know moving forward. So with all of that under our belts, let's go ahead and head to the end of this dark cavern. And next to Hal Tandybuck, we'll find our Cranberry Pie terminal with the challenge ahead. So this is what we're looking at when it comes to the Boria locks. Now in this case, what we need to do for this is we need to be able to fill the same color that we have on these sort of connecting wires to bridge the gap and allow, let's say, I don't know if it's elf magic or electrical current, but whatever it is, it needs to be able to flow across these wires and reach the end to completely unlock the door. Now, as our hint stated, the first thing that we might want to do is go ahead and take a look at the source code for this. So if this is our first lock, let's inspect that element. And what we can see here is, okay, so these are referred to as pins. We have pins 1 through 6, makes sense for a lock. And we have the HTML code here. So if we open up the head section, doesn't look like there's anything particularly interesting in there. And if we open the body, we can see the actual form data here. And this is interesting. So we have a comment, and this comment just seems to have a fairly random set of characters. Well, my first inclination is to take whatever this is and just drop it in that input field and see what happens. So let's copy this element. I will close my developer tools and let's paste that in there, getting rid of those opening and closing carets. Click the go button and look at that. It looks like we have current or elf magic, Christmas magic, whatever that happens to be, going from this node across the lock and into this wire, and it's unlocked. So, okay, based on that input, what was rendered was an image. We know that from our other hint. And it appears that there is continuity here in the color. So if we zoom in on this to get a better picture of it, we can see that there is some kind of formatting, like a stroke or bold characters or something like that, that is causing these characters to slightly connect and create that white space across the lock and open it up. So moving forward, it would appear that we just simply need to match these colors across these various wires to get that lock to unlock. Probably easier said than done, but it seems like we're on track here for the general process that we're trying to do. Okay, so for this next lock, let's just go ahead and try that same input and see what happens. Okay, well, our output was exactly the same, but there's obviously a problem here. We are not touching either this initial wire connection nor this one, and these are not perfectly across from one another like here. So we're going to have to do something to occupy all of this additional space and get that current flowing across those two wires. So let's inspect this again and take a look at the HTML code. And here again, we have the head. Now, in this case, we do have a content security policy in place, but nothing that's particularly relevant to us at the moment. And if we go down to the form, we can see there's another comment here that states to do filter out HTML from user input. Well, that would imply that we can put HTML input in there and it won't be filtered. So that's definitely something worth working with. What we might be able to do is construct, and I'll open up Notepad so we can take a look at how we might do this. Use HTML to our advantage to create a block of text that's large enough to bridge both of these wires. And to do that, we might start by using a span. Not span, but rather span. And then we can place our text in between. And we'll just start with the text that we got from the first block and see how that works out. And to increase the size of this, we can use the style tag. So let's do style and then font size. Let's just start with 100 pixels and see where that gets us. Copy this out, drop it in our input. We can probably close these developer tools for a better view of what's going on here. Okay, well, we can definitely see that the HTML has been processed because we have larger text than we did before. 100 pixels isn't quite enough to make that connection, but it looks like we're on the right track. And there's a couple other things we might want to take note of that are happening here. It doesn't appear as though we're completely closing the gap in color, so there's going to be some modifications we need to make for this. And for what it's worth, we can see that our initial character set is comprised of this @ symbol, ampersands, and a W. Well, we could play around with the different characters and everything in here. First, let's try and get to approximately the correct size. And we can up this by 50 pixels and see where that gets us. Okay, so that definitely gets us closer. It looks like we have the general height correct, but we still are having some issues with how these characters are connecting. There's still black space in between them, and that's not going to allow that circuit to connect. So let's make a few more modifications here. And let's try making bold characters. So we can throw the strong tag in here and see if we can increase the overall width of each of those characters to bridge that gap. Seems to be working, getting a bit closer. It doesn't seem to be having an effect on the @ symbol so much, so maybe we want to substitute out or start to play with the characters in here, and let's just take it to all ampersands and see where that gets us. So really just a trial and error sort of approach to this. And we can see that this isn't quite cutting it either. So let's just go ahead and go with maybe the W characters might have the best chance of connecting. So I'll just throw a couple W's in here and let's see what the results are regarding that. Okay, this is good. So we have these characters, they are connecting. We have some overlap here to where we're getting solid white across, just not quite big enough in this case to cover the width, and we're a little short on the height. And I think that's a pretty easy minor correction to get that. Let's just up this by say 30 pixels and see if that is enough to bridge the gap. And in that case, that worked. So now we have current flowing across here and we have that unlocked. So we can definitely see the process and the methodology here. we're going to be faced with, clearly we're going to be faced with the opportunity to input something. Maybe content security policies based on the hints in the background are going to prevent us from performing certain actions. But I think we're pretty clear on the general approach to how to unlock these locks now. So let's take a look at what we have for pin 3. And let's open up that head. And in this case, we can see that the content security policy has some additional notes in here. So it looks like there's a comment for something to add, but it's not yet implemented. So we're still not really facing anything super difficult as far as content security policies go. Let's look at the body of this and see what the form section states. And again, we have another comment, and this time it's to do filter out JavaScript from user input. So based on this, we can pretty much surmise that what we need to do is leverage JavaScript to in our favor to manipulate text to, again, bridge this gap, much like we did in pin 2. But at this point, maybe we want to step back and take what we know and sort of reanalyze the situation to see if we can work maybe more efficiently with this. We have the opportunity to input text. We know it's going to be rendered as an image. And effectively, what we're just trying to do is get the same color the whole way across this black space, negative space, to connect the wires in a matching color. So what could we do that allows us to define, ideally, we could just set a solid rectangle of color and be done with it. So what would allow us to do that with a text form input? And actually, this is something that we can accomplish by using scalable vector graphics, or SVGs. So I'm going to close this, and let's just jump right back in here to show how this might work. And I'm going to bring Notepad up again. And taking what we've learned, let's try to construct something that's just going to be much quicker and much more efficient at accomplishing the goal that we have here. So what we can do with SVGs, or scalable vector graphics, is define SVG in an opening tag, and we'll close it out. And in this opening tab, in this opening tag, we can define like width and height and everything like that. But let's just start off by doing a really basic shape, because we know all we really need to do is get a big old block of color in there. So let's start with a rectangle, and then we can define the width, the height, and the fill color. So let's first do width, and let's just say width equals 100%. The next is going to be height, and that will also be equal to 100%. So we can define things in percentages or pixels. We can do either for this, but let's just go with the percents and see where that gets us. And then finally, fill color. And in this color, or in this case, we're going to use a fill color of white for these locks. And let's just see how this works for this very first pin. So if we copy that, knowing that there's no input validation or anything on this first lock, let's just test our theory here to see that this is going to accomplish what we want. And sure enough, it does. We get a big old block of solid white, and we make that connection across the wires. Now, we didn't totally cover everything in here. We know that when we were working with this pin, we had a text height of 180 pixels, which didn't quite fill the entire space. So maybe something that we can do to modify this is just define a width and a height of, let's say, 200 pixels. And we'll start there. And we'll do that in the opening tag. So width 200 and height equals 200. And let's go ahead and try that in here. We know it accepts HTML input. Let's see if it accepts this input. Okay, now we filled the entire square. We've made that connection. This is starting to shape up to be something that's fairly straightforward. So from here, now this one we know doesn't filter out JSON input. We need to connect two blue wires. Let's just slightly modify what we have here and see if we can get away with it in this lock as well. So we'll copy this. Just kind of build off of these progressively. And the only thing that we should have to change here is the color, if this works, and go to blue. Copy that, drop it in pin 3, go button, bam. So we've unlocked that one too. No problem with getting that filled in there, and we have a connection. So there's pin 3 out of the way. Now let's see what we need for pin 4. This is where we start to get into the point at which we need to connect different colors of wires. Unfortunately, that's going to be pretty easy for us to handle with the SVG format. But let's see what this one requires or has hidden in the source code. So we're looking at pin 4. And here we have the head. Let's open that up. And we have, we have a script in here. So let's see what that script states. Okay, now this is interesting. We have a sanitize input. And it looks like what this is doing is taking whatever the input text is and it's substituting characters out. And some of the characters that it's substituting are double quotes and these less than, greater than signs that we use to open and close our tags. So this is going to be problematic. If it's indeed sanitizing that input and we can no longer put this in anymore, that is going to be a problem for us. Now let's look at the body field here and see what we have. No comments that are very helpful. And we can see that this sanitize input script is attached to the onBlur function here. So that would beg the question, what does onBlur do exactly? And we can look that up. We can just jump over here and say HTML onBlur. What is the onBlur event? Okay. Call a function when a user leaves an input field. So the onBlur event occurs when an HTML element loses focus. Okay, and this is often used for input fields. The onBlur event is often used with form validation, which is what we have here, when the user leaves a form field. Okay, in that case, the form field is going to be this field right here, and when we click the go button, we're going to lose focus on this form field. So whenever we click out of here, that's indeed going to that's going to activate that sanitize input script, which is then going to screw up our SVG input, and this won't work anymore. But what if there was a way for us to submit the form data without leaving the form field? We only have one field. We don't need to fill multiple fields. So we don't necessarily have to click out of here, assuming that there's another input method. Unfortunately for us, we could try the enter button and see if the enter button, or rather the enter key on our keyboard, works for form submission along with clicking this go button, or in lieu of clicking this go button. But to test that out, first let's build the SVG that should actually make this connection. And we're dealing with two rectangles now. We're dealing with one that's going to connect the white wires and one that's going to connect the blue wires. And they're about 50-50 as far as spacing goes. So all we need to do in here is turn this into something that looks like this. So we'll need to close out our rectangle section and just create a new one right above it. Actually, we can do copy and paste that right in there, substituting white. And then we need about half of this on the top section of the input field, or that negative space, and half of it on the other side. So then what we might do is define sort of, fortunately for us, these shapes allow us to do X and Y positioning within scalable vector graphics. So we could do something like say that X is equal to 0 because we're not changing the left to right orientation, and we're but we are changing the top to bottom orientation. So let's add 0, 0 in for white because that's going to be where we fill the top. And then all we need to do is modify this Y section to occur at 100 pixels. So out of 200 pixels, cutting it in half across the horizontal axis. So starting at 0, 0 on the grid from the top left corner, we're going to fill white to 100% to 100% up until we define a blue rectangle starting in that same position but at 100 pixels lower. Hopefully that makes sense. And if we take this and drop it in, and if our theory is correct, well, let's test this with the go button. So this would be leaving that form field, and this should activate the input sanitization. And it does. Look, it stripped out all of those characters and substituted in the alternative characters. So let's try this by hitting the enter key, and hopefully we won't have to leave the form field to submit our input, and thus we would bypass the onBlur event, and that sanitize input script would never have an opportunity to act on our input. And that's exactly what happens here. So now we've connected those two, lock 4 is unlocked, and I think we're on a roll here. So let's check out the next one. And this gets a little repetitive after a while. This was definitely a trial and error kind of problem when I was working through it. But let's see what we have for pin 5. So pin 5, again, we have a script, and it's another input sanitization script. And this one is just subbing out more characters. So very similar to pin 4. Now let's look at the body. No comments, again, that are particularly helpful. And we can see that that sanitize input script is again linked to that onBlur event. Well, we already know how to bypass that. We just use the enter key without ever leaving the input field, and that script is never going to take effect. So that's not an issue anymore. At this point, all we need to do is construct the appropriate SVG to connect this red and this blue now along a diagonal axis. So we can go ahead and jump in to Notepad, and we should be able to build that fairly easily. And what that's going to look like is, again, just toying with the values here. But if we modify our X and Y axes again to what I found to be, this works well enough, 25 and 80 for the second color, which is blue. And of course, we need to change our top fill color to red, not white, as these are red wires that we're connecting now. This ought to do the trick. And again, not clicking the go button because that's going to activate that input sanitization, but the enter key, not an issue. So you can see that all I did was push the left-hand side of where the blue rectangle starts in just enough by 25 pixels that we still capture this blue wire, but we leave enough space for the red square, which effectively covers the entire block, that there is enough contiguous color here to make that connection as well. So moving forward to pin 6, here we have the most complex set of wires. We have to deal with green, red, and blue, and we have a split on the horizontal and we have a split on the diagonal. But here again, at this point, we already know the process, so it's really just trial and error and fine-tuning and dialing in those parameters within the SVG to accommodate all of the connections. But let's see what we have as far as pin 6 for any kind of input sanitization or any kind of content security policy in here. And looking at pin 6, here we have our head. Nothing, not even a content security policy. Okay, that's kind of interesting. Make sure that I'm looking at the correct one here. It is indeed pin 6. So we have a bunch of iframes. Oh, I'm sorry. We have pin 6 right here. I was looking too far up. Okay, so we do have a content security policy, but nothing special. And in the body here, we have the form field and nothing. No input sanitization here. So this one's kind of a gimme at this point. It's just a matter of fine-tuning the SVG input to make a color path for each of those wire connections. And what this is going to look like, what I found to work for this particular last pin of the lock, is to copy this, start a new one. Of course, we have a new color here, so we need a new rectangle block as well. And why am I typing this out when I can just copy paste? That's way more efficient, so let's do that. Top is going to be green, then to red, then to blue. And for the green, we can leave these default values, 0, 0 for X and Y, and then 100%, 100%. We'll have them all at 100% actually. So we're just manipulating the X and Y values here. And for the red section, we will leave the X at 0, but we're going to move the Y axis of this down 50 pixels. And finally, for the blue section, we're going to have to play with this a little bit more. But I actually found that we can capture everything without even touching the X. So we can, again, leave this at 0. And if we push this down to 115 pixels, it's just going to sneak in and get us what we need. And we don't have any input sanitization here, so we can hit the enter key. We can click the go button. Doesn't matter. It's all good. And as you can see, those values there got us just what we need for this one. But I did make an error. So what I mistakenly did was put in green here, when in fact the color tag that matches these wires is not green, but it is lime. Which of course you can look up on the various color options for all of your HTML and SVG tags and such. So there you go. That is opening up the Boria mine door. It was a little bit of a tedious process, I'll admit, just kind of working through this, figuring out how to set up those SVG parameters to make the necessary connections. But then once you get to that point, I think it's pretty straightforward. It's just a matter of fine tuning. If you were doing all of this by trying to do text manipulation, I didn't even bother to try by the time I got to pin 3. So I would imagine it's quite a bit more difficult, but this definitely makes that process a little simpler. So that would be this challenge. Now, normally we would go to finish off the room and retrieve the web ring in this case. But as I mentioned in a previous video, I actually was not able to solve the next challenge, at least not in time before the event officially ended. And that challenge was Glamterial's Fountain, a 5 out of 5, so a difficult challenge. Not one that I haven't gone and looked up the solution. I'll probably come back to it, but I'm not going to do a walkthrough for it because, again, I'm sure other people have walkthroughs and how-tos on this one that were able to figure it out. So for the next video, we will leave off with the web ring and we will go into the first challenge of the cloud ring, which is going to be an easy challenge again, and it's an intro to the AWS CLI. So until then, take care, everyone. Thank you for watching. I really appreciate it, and I will talk to you later.